Hey, welcome back. So we're going to talk about creating prime factor trees and where can this video help us in the future. Prime factor trees can help us figure out greatest common factors. They can also help us when we get into simplifying square roots a little bit later down the road. So they come back. It's just something that is helpful. So if I can click, there we go. We're just going to jump in with examples. Nothing to really explain. We're just jumping in examples. So we're going to do 3 numbers. Now with the prime factor tree, our goal is to get the prime numbers, the list of prime numbers that multiply to our number that we're starting with. So starting with 12. What our tree allows is instead of just having to break down all the prime numbers, we're going to go with numbers that we know multiply into it. So the trees allow us to create in many different forms. There are multiple ways to do it. Create these prime factors. So for like instance 12, I just need 2 numbers that multiply to 12, right? I can choose 2 and 6 or 3 and 4. It doesn't matter. So say I do 2 and 6, right? My next one is 2 is prime. It stays. But 6 breaks down more, and that goes to 2 and 3. Now, if you're like, well, what if I wanted to do 3 and 4? Does that make this different? No. So if we say chose the 3 and 4, right? The 3 stays. That's my prime number. The 4 becomes 2 and 2. Guess what? We still have 2, 2, and 3. So when I go to write what my prime factorization is for 12, I start with the smallest, but it really doesn't matter. So 2, and how many 2's do I have? I have 2 of them, so I'm going to write it as 2 squared. So if you forgot about exponents, exponents is our repeated multiplication, and then times 3. The 6 is no longer part of it because the 2 times the 3 that it became, that's where our 6 still exists, but in smaller numbers. So this is our prime factorization. If you notice, even if we did 3 and 4, we still come up with 2 squared times 3. So it doesn't matter the number we choose. So say for 20. Now, the bigger the numbers you choose that divide into it, the fewer trees you have to go, right? But if you look at it and you're like, well, it's even, I know 2 goes into it, that's fine too, right? In the end, we're still going to get to the same result. So when I look at 20, I'm going to go with the fact that 4 and 5 go into it. So that's 4 times 5. I lucked out. 5 is already a prime number. 4 is 2 times 2. And so when I go to write this prime factorization, again, I've got 2 2's, so that's 2 squared. If I had 3 2's, then I'd write 2 to the 3rd power times 5. That's my prime factorization. And then that's it. Okay, moving on. 35. Right? It's not even, so 2 won't go into it. If we're using those divisibility rules, 3 plus 5 is 8, not divisible by 3 or 9, right? But it has a 5. So I'm going to divide it by 5, and I get 5 and 7. Well, they're both prime numbers, so my prime factorization is just 5 times 7, and that's it. There's no squares because there's not multiple numbers. Okay, so if you're like, oh, Mrs. Cartwright, I still am not confident. Can we do something? Those are some pretty small numbers. Can we do a bigger number? Yes, we can. We'll do one more. We're going to do 84, right? We're getting a little bit bigger, but not too big. We're not getting too big for our britches here. Okay, 84. I'm looking at it. I know 4 goes into 8 and 4 goes into 4. So instead of choosing 2, I'm just going to jump in and choose 4, right? Oh, I could go bigger, but we're going to go, I already made the decision. I'm going with 4, right? What I decided, I had added and realized that 3 went into it. And since it's even and 3 goes into it, 6 could go into it. Just so you know where my brain went. But I already told you I was doing 4. So we're sticking with 4. 4 goes in to 8 twice and into 4 once. So it's 4 and 21. I know 4 becomes 2 and 2. Right? Neither one of these are prime, so they both have to break down. 21 is 3 and 7. And then we looked out, and at that point, we now have all prime numbers. So, again, the 4 and the 21 no longer matter, because the 4 and the 21 were not my prime factors. My prime factors is this 2 times 2. Really, all this is 2 times 2 times 3 times 7. Oops, I don't know why I'm putting a dot after the 7. And so all I'm doing is when I do that prime factorization, instead of writing it as 2 times 2, I'm just making it 2 squared times 3 times 7. And there's my prime factors. And that's how we do prime factor trees. And that is it. There's nothing more to it. Okay? Again, as you're working on it, give it your best shot. If you need some help, turn to your neighbor. And then if there are still ones that you're like, I'm not sure, I will answer your questions when I return. Have a good one.